Let's talk about derivative problems that use the product rule, the quotient rule, and the chain rule. So not every example I do here is going to use all these rules together, but each of them is going to use at least two different derivative rules on top of like the basic like power rule stuff that we have memorized. Okay, so the first one we're going to do, you can see at the top of the screen here. So I want to kind of assess, like, I definitely don't have a derivative rule for all of this. So I want to decide, like, am I looking at multiplication, two things multiplied, two things divided, or things like composed within each other? And I would say this is composed within each other, right? This is function composition because it's all this junk in the parentheses raised to the 10th power. So I want to start off by seeing this as f of g, f of g of x. There we go. And I'm going to use the chain rule formula, f prime of g times g prime. Okay, so let's take apart the pieces here. If this is f of g of x, I'm going to take the outermost operation and make it the f in my scratch work. So that's going to be x to the 10th power, because this is all stuff plugged into x to the 10th power. So the f is x to the 10, and the g is everything inside of it. Okay, so I want to double check in this moment. If I plugged this into here, would I have my original function? Yes, so we can keep going. All right, so I need the blue f prime and blue g prime. I get 10x to the 9 for f prime. For g prime, I know that the derivative of 6 is 0, so I really just need to focus here. But I don't have a derivative rule that just covers like all of this, so I need to see it as either multiplication, division, or composition. And I would say this is another composition, right? This is the cube root function on the outside with 2x minus 1 plugged into it. So I'm going to switch into another chain rule. This is f of g, where the f is the cube root of x, which is the same as x to the 1/3 power. And then the g is 2x minus 1 plugged into it. All right, so if the cube root is the same as the 1/3 power, this derivative is 1/3 x to the negative 2/3. And then the g prime is just a 2. So I can use this green information to get blue g prime. So this was the chain rule. So I want to do f prime of g times g prime. So outer prime of inner times inner prime. So g prime of something is 1/3 whatever to the negative 2/3. And it's supposed to be f prime of g. So this 2x minus 1 is going to be the input in these parentheses. And then times g prime gives me times this 2. If you want, you could combine the 1/3 and the times 2 to a 2/3, or you could just leave it exactly how it is here. All right, now that I've done this work, I have all 4 pieces of scratch work for my chain rule overall. So now I'll come back and do the derivative of the entire function. So the overall f prime of x, using the blue, I'm going to do f prime of g times g prime. So f prime with something plugged into it is 10 times whatever to the 9. And then what's being plugged into it is g. So I'll have 6 plus the cube root. 2x minus 1. So that's my f prime of g. And then times g prime will be times all of this here. And because it's all multiplied, it doesn't have to have parentheses additionally on the outside, but it wouldn't be wrong to have them. Anything equivalent to that is a good final answer. All right, let's do another one. This function g of x, again, I don't have one derivative rule that covers all of this, so I have to decide, am I looking overall at two things multiplied, two things divided, or something plugged into something else? While we do definitely have composition over here with the cubic function inside the square root, I would say overall, I'm not going to be able to find an f and g where this is all f of g of x. But what I can do is find an f and g where this is f times g of x, right? Then the division is very clear between the two terms. So I'm going to decide to do the product rule as like my overall rule. So when I go to do like my final answer, it'll be f prime g plus g prime f. Okay, so in my product rule, the f is x squared minus 1 over x, and the g is square root of x cubed minus 9. All right, so now I need f prime and g prime for these choices for my scratch work. For the derivative of this, x squared is going to be a regular power rule. 1 over x, I just want to remember, is actually x to the negative 1 power. So its derivative is negative 1 x to the negative 2. So I have a negative from the derivative rule and subtraction from the original function. So these will combine to a plus sign. Okay. For g prime over here, I can't do this with regular derivative rules, so I have to switch again into thinking, am I looking at multiplication, division, or composition? Because I have the square root over everything, this is composition, so I'm going to do a chain rule here. So the outer operation is the root. The inner operation, I didn't leave enough space for, but it's x cubed minus 9. So then the f prime is 1/2 x to the negative 1/2. And then the g prime is 3x squared. So for blue g prime, I'm going to use this green scratch work, if we can kind of disentangle it, and do f prime of g times g prime. So f prime of something is 1/2 whatever to the negative 1/2. And I'm plugging in g, which is x cubed minus 9. That's f prime of g. And then times g prime, we'll throw a 3x squared at the end of it. All right, so for my overall product rule, I now have all 4 blue pieces that I need. So I can put together my final answer. So the product rule overall that we were doing with the blue scratch work is f prime g plus g prime f. So that's what I'm going to steal from the blue. So f prime g plus g prime f. F prime is 2x, and I'm going to turn this minus minus into a plus here. 1x to the negative 2. You don't have to write the times 1 there, but I just don't want to change it too much. All right, f prime g plus g prime f. And that is my glorious final answer for that derivative. All right, I've got 2 more in the video. I'm going to start to skip a little bit of scratch work to see how we feel about it. All right, so h of x here, same thing as before, so we don't have a rule that covers all of this for sure. So we need to decide, is this an f times g, an f divided by g, or an f of g with stuff plugged into it? And this is tricky because this is going to have 3 separate rules in it. There is multiplication here between functions, but they're under a square root together. So if I'm going to say just like one pick to get started, I'm going to have to say this is composition where the outer operation is that square root. So I'm going to do chain rule overall. So my outer function f here will be the square root. The inner function g will just be everything else, and we'll kind of deal with that as its own project. So my f is square root of x. The g is x to the 7 times the cube root of 3x squared minus 1. Okay, so f prime here is nice. This will be 1/2 x to the negative 1/2. And the g prime is going to take a ton more work. So again, we say overall, is this multiplication, division, or composition? There is composition happening, but it's not like the overall picture. I can't pick like one f of g that this all is. But this is multiplication, right? I can see the product rule here. So this would be the f, and this would be the g in the product rule. All right. So the product rule, I'm going to start to skip a little bit of the scratch work for space. The product rule would be f prime g plus g prime f. So I'm going to partially put that together. So f prime is the derivative of this, 7x to the 6, times g, plus g prime f. So I'm going to write the x to the 7 for the f first, so I don't forget it. And now what I have to fill in here is the derivative of cube root of 3x squared minus 1. And I'm almost out of space, so maybe I'll kind of do that and say it's going to go in this spot times the x to the 7. So for this guy's derivative, this is composition, right? Cube root of some stuff. So I'm going to do the chain rule for this moment. The outer operation is the cube root, and then the 3x squared minus 1 is the inner, and then we're finally like at the core of the formula, and we can stop doing derivative rules. All right, so I want outer prime of inner times inner prime. So outer prime is the derivative of the cube root part. That's outer prime of inner, and then times inner prime is times the derivative of 3x squared minus 1, which is 6x. You could simplify this a little bit before the next step because you have a 1/3 and a times 6. You could combine these into just a 2, or you could leave them how they are. I'll make them a 2 in the next step just to make things a little bit easier to look at. Okay, so g prime is pretty big, but I have blue f, f prime, g, g prime for my original chain rule. So now I'm going to put all this together in the chain rule formula. All right, so overall derivative, starting way over here so I have enough space, chain rule. So f prime of g times this monster g prime. All right, so f prime of g, so I'm going to put this whole thing in those parentheses, times g prime. So right next to this, I'm just going to put this entire g prime that I had here. And again, this just looks a teeny bit different from what I had here because the 1/3 and the 6 have combined to be this 2. Everything else is exactly how it was. And that's my final answer. Whew. All right, that one's pretty much as bad as it gets. Let's do one more example and then we'll call it a video. All right, so again, no basic derivative rule covers all of this. So we have to decide, is it two things multiplied, divided, or composed? There's definitely composition going on here, but overall, I can pick this as something divided by something else, right? That's my f and g, and this is a quotient. So my overall derivative formula is going to be the quotient rule here. So I'm going to kick this off and show you how this would look if you don't do any scratch work, always optional. So I'm going to have low d high. All right, so I have the lower function just as is, and now I want the derivative of what I've chosen as f, so the square root of stuff. I see that square root on top of everything, and I say, you're a chain rule problem. So I have outer prime, oops, missed my x, outer prime of inner, and then times inner prime is going to be times the derivative of x cubed plus 4x. So that gives me 3x squared plus 4. All right, so this is low d high minus high d low. So now in this spot, I need the derivative of this denominator. It's a bunch of stuff raised to the third power. So I'm going to do the chain rule where the outer function is the cubed function. So I have outer prime of inner times inner prime, which is just 2 as the derivative of 2x minus 3. Almost there. So this is all over the square of what's below. So it's all this squared. You could write this as 2x minus 3 cubed and then another parentheses squared. Let me show this on this side. So 2x minus 3 cubed squared. But that looks pretty awkward. This answer is bad enough. One option you could do is we multiply exponents when they're in this kind of position. So this overall exponent is 3 times 2 is 6. So I'll write 2x minus 3 to the 6th power. And that is as bad as it gets for now.